Let's dive in. Today, we're putting on our detective hats and taking a closer look at the everyday substances all around us, trying to figure out their secret identities. So get ready, because we're about to crack a few chemical cases.
So here's the thing. We're always told, don't just taste something to find out what it is, right? And for very good reason. But that leaves us with a real puzzle. How do we figure out if something is sour or bitter or soapy without actually, tasting it? How can we safely uncover its true chemical nature?
Well, every good detective needs a secret weapon, a special tool of the trade. And in chemistry, our tool is kind of like a chemical chameleon, something that changes color to reveal the truth.
And that tool has a name. Looking at the original notes we're working from, one word is our biggest clue: indicator. This single word is the key to solving our entire mystery.
So, what is an indicator? It's actually wonderfully simple. It's just a substance that gives us a clear signal, a sign, that tells us if what we're testing is acidic, basic, or that third option, neutral. It basically does the dangerous tasting for us.
Okay, so with our new tool, this indicator, we can start identifying the main suspects in our chemical lineup. And they usually fall into two big categories: acids and bases.
Let's break down the classic profiles of our two main suspects. On one side, you've got acids. The notes tell us they're typically sour. Think of a lemon. Then on the other side, we have bases. These are usually bitter and have that kind of slippery, soapy feel. But, and I love this little detail from the notes, it's not always so simple. Yeah, the general rule is bitter means basic, but nature loves to throw us a curveball. Take a bitter gourd, for example. The name says it all, it's bitter, but chemically, it's not a base. It's a great reminder that in science, there are always these fascinating exceptions to the rule.
Right, so we've got our two main players, acids and bases. But there's a third group we can't forget about, the neutral substances. And they're exactly what they sound like. They aren't acidic or basic. The perfect example, pure water. Okay, so we know what we're looking for. Now it's time to meet our star detective, our #1 go-to indicator. Its name is litmus, and it's basically nature's own secret agent.
So let's open up the case file on this litmus stuff. What's really cool, as the notes point out, is that this isn't something cooked up in a lab. Nope. It's a natural dye that's actually extracted from lichens. Those interesting organisms you see growing on rocks and trees? And because it's so reliable, it has become the classic acid-base indicator.
And now for the really cool part, the big reveal. How does litmus actually point the finger and tell us a substance's identity? Well, it all comes down to a super dramatic color change.
Okay, watch this. Let's start with a plain strip of neutral litmus paper. Now we take our first mystery substance, just one little drop, and boom, it turns bright red. Just like that. That's our signal. Case closed on this one. The substance is an acid.
All right, let's try that again with a different suspect. We grab a new, clean strip of litmus paper, we bring in our second mystery substance, add a drop, and whoa! This time it transforms into a deep blue. See? It's a totally different signal, telling us we're looking at a base. It's so simple, right? Red for acid, blue for base. Super clear and really effective.
And this is where it gets really useful. The notes give us a perfect real-world example: lime water, which is just a solution of calcium hydroxide. Since we know that's a base, what would happen if you tested it? Exactly. That litmus paper would turn blue, just like we saw.
Okay, this litmus paper sounds amazing, but it brings up a really good practical question, one that our original note-taker also thought of. What happens if you don't have any special litmus paper just lying around? What do you do then? Well, the notes themselves give us a pretty exciting clue. Litmus isn't the only game in town. The source text says it right there. There are some natural indicators. This suggests that nature has a whole team of detectives just waiting for us to find them.
And that really brings us full circle. We've seen that litmus comes from lichens, which is already pretty cool, but it makes you wonder, doesn't it? What other chemical detectives might be hiding in plain